These are some problems from the lessons from 9.01, 9.02, and similar to the questions on the quiz for 9.03. So I'm going to start with question 1, and we're comparing two functions, one written in quadratic form, one shown in a table. And it says, which function has the least minimum value and what are its coordinates? So we have to find the minimum values for both and see which one is least. And then don't just give the x or the y, but give both coordinates. So when you look at a table, you can find the maximum or minimum values by just looking at the coordinates. Remember with a quadratic, we're going to go down in value and then we're going to come back up in value. Or we're going to go up in value and then we're going to go back down. And you can see that, see my x values go up by 1s, but my y value goes down, down, and then back up again. So the point at which it turns and goes back up, that's your vertex. Okay, those are your vertex or vertices. It's also your minimum value if your quadratic is opening up, or it's your maximum value if your quadratic is opening down. So this has a minimum value. This has a maximum value. It's the highest y value that you're going to get in that quadratic. That's the lowest y value. So for this function, you can see that it starts up and it goes down and it goes down more. And then at -1, it flips and goes back up again. So here is my vertex. I can tell because the 2 on either side is exactly the same distance. So my minimum value is -1. Now I'm going to do the same thing here. But I need to find my minimum value from this equation. And I'm going to use the formula for axis of symmetry, because the axis of symmetry will tell me what my vertex is, or at what x value my vertex is. So I'm going to take -b over 2a, because this is my formula for axis of symmetry. And I'm going to plug in b and a from this formula, which is here and here. There is nothing here for a, so I can plug in a 1. Make sure you plug in -4 for b. So negative of -4 over 2 times 1. All right, negative and negative cancel. And 4 over 2 is 2. This is my axis of symmetry. I'm going to draw a line here. It is the x value through the vertex. And you see, I could have the same axis of symmetry and have 2 completely different vertex coordinates. So what I need to do now is I'm going to take this. This is x equals 2. I'm going to plug it back into this function to see what the y value would be at my vertex. All right, so this is x is 2. I'm going to take this equation and I'm going to rewrite it with the 2 in place of all the x's. So 2 squared is 4. -4 times 2 is -8. And 4 and -8 and 4 and 4 make 0. So for function 1, my vertex is at 2, 0. So I have an equation that, because it's a regular quadratic, it looks like this. It's not negative here. My A is not negative, so it's not flipped upside down. So I do have a quadratic like this, which means my vertex is my minimum value, and my vertex here is at 2, 0. So my minimum value for my y is 0 for this. My minimum value for function 2 is -1. So function 2 has the least minimum value. When x is 1, y is -1. So it's 1, -1 is my answer. For question 2, between which x values is the function decreasing? I wrote this a little bit simpler than the question was on the quiz, but see, they gave you like, is it decreasing between x is 1 and x is 2? We're going to go through each of these pieces and we're going to see, is it decreasing or increasing? So you can see my x values, I went from -2 up to -1, up to 0, up to 1. I went up 1 each time. And I think that's how all the questions in the lesson and the quizzes were, which makes it a little bit easier. You can see that it's going up by 1 each time. So now I want to look at my y values. G of x is just y. So from 6 to 4, it's going down, right? Then from 4 to 6, it's going up. And from 6 to 12, it's going up. It doesn't really matter by how much. I just did this just because there are other problems where you will have to find the slope. But we just want to see, when is it decreasing? So from x of -2 to x of -1, it's decreasing. So from x of -2 to x of -1, g of x is decreasing. So imagine it's going down, you hit the vertex, and it goes back up again. All right, question 3. And I'm sorry, this is messy. I wrote the wrong numbers here, so I had to rewrite it up here, but I'd already written all of this. What does the average rate of change of f of x from x equals 1 to x equals 3 represent? And this is the question out of the lesson again. So we want to see x is seconds, f of x is height of a ball. So we have a negative here, which means my quadratic looks like this. So I have a ball going up in the air, hitting and going back down. So I want to see the rate of change of f of x, and I want it from the points x equals 1 to x equals 3. Hopefully you can hear me over my dogs. All right, so I'm going to take this equation and I'm going to plug in x equals 1 and solve for y. Then I'm going to plug in x equals 3 and solve for y. Let's just do a little when x is 1 and when x is 3. I'm going to find y. You know how I like my function tables. So we're going to take negative 1 squared plus 2 times 1 plus 7. 1 squared is 1, but then it's a negative. So this is -1 plus 2 plus 7. So this is a total of 8. So when x is 1, y is 8. And then I'm going to do the same thing, but I'm going to plug in a 3 for x. Here, I'm going to separate that so you can see. -3 squared plus 2 times 3 plus 7. So this is -9 plus 6 plus 7. -3 and 7 make 4. So my average rate of change from f of x from x equals 1 to x equals 3. So now I can find what my rate of change is from these values. So x went from 1 to 3, so it's going up 2. And y went from 8 to 4, so it's going down 4. So y over x tells me -4 over 2. That means my average rate of change is -2. And that means from x equals 1 to x equals 3, my ball is going down